The basic question: do heavier people burn more energy? Metabolic rate, the rate at which the body consumes energy, is important in studies of weight gain, dieting, and exercise. We have data on the lean body mass and resting metabolic rate for 12 women who are subjects in a study of dieting. Lean body mass, given in kilograms, is a person's weight leaving out all fat. Metabolic rate is measured in calories burned per 24 hours. The researchers believe that lean body mass is an important influence on metabolic rate. Question A asks to use your calculator to help sketch a scatter plot to examine the researcher's belief. So I put the mass on the x-axis and I put the rate on the y-axis, and you can see as the mass goes up, so does the rate. This means, as question B asks, to describe the direction, form, and strength of a relationship. This means that this scatter plot is positive and also linear, and it shows that the strength of the scatter plot is weakly positive. You can see that it is positive because it goes up as it goes to the right. You can see that it's linear because if you put a line right here, all the points would slightly follow that. And the reason why it's weakly strong is because as it goes up, the data isn't really staying in a direct line. It's spreading out a little bit above and below where the line of in between would be, and that just shows the strength. Advanced question. The data in the accompanying table are from the paper 6-Minute Walk Test in Children and Adolescents. Boys completed a test that measures the distance that the subject can walk on a flat, hard surface in 6 minutes. For each age group shown in the table, the median distance walked by the boys in that age group is given. Question A. Determine the least squares regression line and interpret the meaning of its slope. So on my graph, you can see the X has the representative age groups, and the Y has the median walk distance going up. And here is my least squares regression line. You can see that it goes up and it's in a positive correlation with the data. Here is how I found it. I used this formula and I plugged in my y equals and it gave me this line. I plotted it first and then I put my points on there second. You can see that as a kid gets older, the farther he can walk or she can walk, it goes up. That is the meaning of the slope. Question B. Compute the residuals and construct a residual plot. Determine if there are any unusual features in the residual plot, as well as their meaning. What does it mean if there are no unusual features? Okay, so here's my residual plot. You can see representative age on the X and residuals on the Y. And it says determine if there are any unusual features in the residual plot, as well as their meaning. There are no unusual features in this plot because all of the points are scattered randomly. This means that the least squares regression line fits the data shown in part A here correctly. AP question. Commercial airlines need to know the operating cost per hour of flight for each plane in their fleet. In a study of the relationship between operating cost per hour and number of passenger seats, investigators computed the regression of operating cost per hour on the number of passenger seats. The 12 sample aircraft used in the study included planes with as few as 216 passenger seats and planes with as many as 410 passenger seats. Operating cost per hour ranged between $3,600 and $7,800. Some computer output from a regression analysis of these data is shown below. Question A. What is the equation of the least squares regression line that describes the relationship between operating cost per hour and number of passenger seats in the plane? Define any variables using this equation. So the equation is y hat is equal to 1,136 plus 14.673 times x. So x is equal to the number of passenger seats and y hat is equal to the predicted operating cost. I got these values from the coefficient, predictor, and here's the constant in the seats. And I got that from right here. Question B. What is the value of the correlation coefficient for operating cost per hour and number of passenger seats in the plane? Interpret this correlation. So they give you the R squared, which is 57%, which is also 0.57. And so to find the R, you just take the square root of 0.57, and that is equal to 0.75490. And this means that the correlation is strong because anything between 0.7 and 1 is a strong correlation. Question C. Suppose that you want to describe the relationship between operating cost per hour and number of passenger seats in the plane for planes only in the range of 250 to 350 seats. Does the line shown in the scatter plot still provide the best description of the relationship for data in this range? Why or why not? So here's a sketch of the graph that they give you, and here you can see the number of passenger seats on my X, and on my Y axis you can see the operating cost per hour. And so it is asking if the range of 250 to 350, these values right here, if this line shows a good representation for that data. And the answer to that is no, because these three values up here and these two values down here definitely affect the way the line is shown. The real correlation of this data is shown in a negative way, that the number of passenger seats and the operating cost per hour is negative. So therefore this line right here, the least squares regression line, is not a good representation for this set of data.